10.3, which is we're going to pick up with cone. A cone and a cylinder basically are similar to pyramids and prisms. The difference is that their base is a circle. So similar to pyramids and prisms, except the base is a circle. I think the book calls it a disc. I don't know why. I don't think it really makes a difference. Okay. Oops, such a badly drawn circle. I will do my best. Okay. So it's going to be kind of wonky since we're looking at it from the side. So this would be a cone. And because that straight up to the top point, that forms a right angle, we would call this a right cone. A right cylinder would be, oops, trying to draw these lines as straight as I can. There we go. Would be when the right angle is formed right there. So that would be a right cylinder. And then of course we could cause the top point, which by the way is called the vertex point. We could cause the vertex point to be wonky, right, off to the side. And then they give it the name oblique when that happens. So this would be an example of an oblique cone. And this is called a vertex point, which I don't think I said when I talked about the pyramids in the last section. But yeah, they call that a pyramid. I mean, sorry, a vertex point. And then I've been referring to that, but that's the base. Okay. Let me go ahead and label that to add it. So we have that terminology under our belt. I've used that a few times. Hopefully you picked up on what that meant. Okay, and then of course I could do an oblique cylinder, basically be a kind of a cone that's slanted. I'm not going to draw that for right now. Now a sphere is the next shape we're going to center in on. All right. And I love the definition of sphere. It's actually kind of a fun definition. And I may have defined this before, but I'm going to do it again. So a sphere is a set of points in space that are the same distance from a fixed point. We call that fixed point, by the way, the center of the sphere. And the idea is that if I draw a sphere, usually I just start by drawing a circle. Oh, such a lopsided circle. Try that again. I don't know if that's all that much better. One more time. It's best I can do. And then I usually draw kind of like that. So here's the center. And the idea is this distance from that to any point out on the sphere. Let's say it's that point right there. Or maybe it's, you know, to some point over here. Those are all the same point and distance. And that distance, by the way, is called the radius. The radius is the distance from a point on the surface or on the sphere to the center. And of course, it's similar to the radius that we see on a circle. So it would also be this length right there. And it has a diameter just like we would for a circle. The distance from through the center would be the diameter. Is the distance from one point on the sphere through the center to a point on the opposite side. Of course, its length would be 2 radii, right? That's the plural of radius. Okay, now some more terminology for spheres. So on a sphere, let me go ahead and attempt to draw another one. Be a little bit painful. All right, good enough for right now. It's a little bit squished, but that's fine. Okay. If you have 2 points on a sphere here, let's kind of visualize these 2 points where we could see it. It looks like a smile. Those 2 points that are connected, let's say they kind of connect like that, that is called an arc. An arc. And here, let me kind of put little arrows on them to represent that arc. All right. So arc has actually 2 possibilities. Like you could have the arc be going the shortest distance or the longest distance if you connected it the long way around. Okay. But that arc connecting the 2 points, that's what we call that. We do have this idea with spheres that connects to the globe, the Earth. And we have some terminology we use for that. So let's talk about that terminology. So first of all, where I keep drawing this kind of center, right? We typically, if we're thinking of the Earth, we typically call that the equator, right? And the equator is what's called a latitude on the Earth. So all of the lines that kind of go this way on the Earth, all the kind of arcs that we create like this, oh, it's so badly drawn, I'm so sorry. These are called latitudes. This one's special, it's the equator. And the equator represents 0 degrees latitude. The top point, when we finally reach the top of the Earth, that is 90 degrees. Okay. And when we go below, it has a 90 degree as well at the bottom. But we indicate north and south, right? North latitude versus southern latitude. Then we have the vertical lines that connect points to points. And these are called longitudes. So the red ones are longitude. We do have a 0 degrees longitude. I'm trying to remember the 0 degrees longitude, if it has a special name. I don't think it does. North and South Pole, right? We kind of could call that top point and bottom point, the North Pole, the South Pole. And they often call these meridians of longitude. That's another phrase they use. Meridian. Here, I'm going to put that up a bit. Or no, here, let me just write it below. Meridians of longitude. And as you kind of see, it places the Earth in this pattern where we can locate places on the Earth based on the latitude and longitude and the degrees. Now, they do spend a little time, because it's a little bit difficult, talking about map projections of the Earth. And I would encourage you to look at the pictures on page 670. They have figure, here, let me put that figure 10.57 shows the different ways they form, but theirs are much, much better. So if you were to take the Earth, and here I'm going to draw a little bit smaller sphere this time. So there's the Earth. And you were to kind of surround it with a cone. A cone. Pretend that that's straight. Wow. Allison, draw it straight. There we go. So, it was a cone, and project the Earth onto the cone, right? Almost like putting a light bulb at the center of the Earth and project it on a cylindrical projection. And if you were to unfold that cylindrical projection, it would kind of form what we're used to seeing as rectangle of the map. All right. So they even kind of take the point of dividing that, if you were to take this cone and like slice through it and open it up, it would look like a rectangular map with the Earth completely spread over the map. Now, as you could kind of see, if I'm lighting up the Earth and looking at it on this cone, the biggest distortions of the Earth are going to occur at the North and South Pole. And the best accuracy is going to occur near the equator. Note. Regions close to the equator are most accurate. And then closer to the poles, it is most distorted. So that's why when you look at those kind of flat maps, Antarctica looks huge. It's like the entire length of the map. That's because if you're projecting Antarctica onto this cylinder, it would like end up taking the whole bottom because of the way it would project out. All right. Another type of map that we might use is a cylinder, or sorry, a conic projection. So here, let me go ahead and draw my Earth again. There's the Earth. Oh, it's so bad. I'm sorry. I have to fix it. Got to at least connect, even if it's a little wonky. There we go. If you were to do like a cone, and you were to kind of set a cone on top here, like that. And with the conic projection, you're placing the cone over the pole, like the North or South Pole. So it's kind of hovering right over North or South Pole. All right. These would kind of you'd still be able to create a map out of this, but it does look a little bit distorted. And what it is going to give us is a more accurate map at the poles as opposed to the equator this time. All right. So this type of map, oops, let me write this in red, sorry, to be consistent. Note, this type of map is commonly used. Oops, that's not how you. It's commonly used for countries that lie in an east-west direction. And are, wow, that's such a sad eye. Let me fix that. There we go. And are middle latitude countries. Oh, I just realized the implication being that it's probably better for middle latitude. Interesting. I think I said that backwards then. I think I said it would be better at the poles, but that may not be the case. Sorry about that. Okay. The last type of map that we'll see is a projection onto a plane. So like if I had like the ability to put a plane right here, all right there, and we project the information from the Earth onto that plane. Oops. Okay. That's called a plane projection. The problem with a plane projection is that it has the advantage that distortion is uniform. So what it distorts, it's uniformly distorting. As it's projecting. So it has uniform distortion. And they're often used for hemispheres and the pole and maps of like the Arctic and the Antarctic. Arctic and Antarctic. Wow, helps when you can spell. There we go. And those are kind of the basics for the map projections. There isn't a lot. They really just, the homework kind of asks questions about maybe what's most appropriate to use for each, like based on what you're trying to map. But they do use these kind of space figures in these mappings. In particular, they use the cylinder, the cone, and the plane when creating maps. And there is distortion when you do mapping. There is distortion that occurs, and it kind of can. And that's it for that section.